Welcome, Calculus BC. This is lesson 2-3, implicit differentiation. Let's begin. So, let's talk about explicit equations. So, explicit equations are equations that are in like the y equals form, or f of x equals. So, like y equals x squared, y equals this, y equals this. So that means explicit. And definition means like you're explicitly saying y equals something in terms of x. So it's very explicit in what y equals. Implicit equations are equations where the x's and y's are mixed. So another way to say it, it's not in the y equals form. So what does that look like? Well, here's some examples. X squared plus y squared equals 1. X's and y's are mixed up. This equation right here, x times a y, and there's also y squared. Even something simple like x times y equals 1, which you could rearrange into the explicit form, dividing by x on both sides, go y equals 1 over x. But this is the implicit form of this explicit equation. So the relationship between x and y are only implied in these cases. It's not saying, well, y does equal this thing in terms of x. What does that mean in calculus? We can differentiate implicit equations. We know how to do the explicit ones. It's just you do the derivative. Well, in this procedure, it's a little different. And here's some steps for that. So you have to differentiate everything with respect to x. That means you're doing d of dx on both sides, which is just what you normally do. And then just if we wanted to solve for y prime, we collected all the y prime terms on one side, or dy dx. Sometimes it's easier to write as y prime because it's less work. And then we factored out the y prime and divided. But the key thing to understand what you're doing here is the y prime hook-on factor. They say that in the book, but so whenever you're deriving a y, you have to like chain rule a y prime at the end. So that's like the only big difference. Like you're deriving the y's, but when you ever derive y, you got to do like a dy dx or a y prime at the end. So let's see some examples of what that looks like. So let's say in this example, I want to find dy over dx. So implicit differentiation. So what you're going to do is you're going to differentiate both sides. So if I showed the work, I would d of dx this and d or dx this thing. So this just means the derivative of x, and that's 1. Over here, derivative of y squared, well, derivative of something squared is 2 times that something, or y. And then you go times dy over dx. Or you could have said, let's say I don't like doing dy over dx. I just want to say times y prime. Easier to write. So then I want to isolate dy dx or y prime. So what I'm going to do is divide both sides by 2y. And these cancel. So I get my y prime equals 1 over 2y. So that's my answer. That's my dy dx. All right, let's do something a little bit more complicated. So this has a little bit more mixed up. I want to find the y prime. So differentiate each of these. That's just going to be 2x. And differentiate that. It's going to be negative 6y squared and then times y prime plus 3 equals 0. So I want to isolate the y prime. So that means I want to get these non-y prime terms to the other side. So I subtract 2x and subtract 3 on both sides. So what I'll get is these will cancel out. I'll get negative 6y squared times y prime equals negative 2x minus 3. I want to isolate the y prime, so I'll divide by negative 6xy squared on both sides. Negative 6y squared. So cancel. My y prime is going to equal negative 2x minus 3 over negative 6y squared. And I can leave it just like that. All right, let's try a different example. So I want to find double y prime in terms of y. And usually it says in terms of y and x. So that means you're not going to leave dy dx's or y prime in the final answer. So I'll show you what this looks like. So differentiating this equation, you got to do it twice. So I'm going to do it once, and I'm going to get 2x plus 2y y prime equals 0. Okay, so the first step, you just want to isolate. You want to isolate and find your y prime. So subtracting 2x on both sides, I get 2y times y prime equals negative 2x. And then divide by 2y on both sides, my y prime equals negative 2x divided by 2y, which I can just simplify as negative x over y. Cool. Now we're going to find y double prime. So guess what? I'm going to say find y double prime. What you're going to do is differentiate this equation. So I go y prime equals negative x over y. Okay, so derive everything again. Well, derivative of y prime is just y double prime. Derivative of this, so I got to use my quotient rule. So f and g, that means your f prime is going to be -1. G prime is going to be just 1 times y prime, so y prime. And so I'm going to plug that in. So it's going to be -1 times y minus -x times y prime all over y squared. Now I could say, yeah, that's an answer, or I could clean it up a little bit. Let's write it as -y plus xy prime over y squared. But I want to have this answers in terms of y and x. So what that means is I got to get rid of this y prime. I got to substitute in for this y prime. Well, I already know that y prime equals -x over y. So this is like the kicker here you got to do. So I'm going to rewrite that as -y plus x times -x over y squared. And you can simplify this and clean it up, but that's the idea. You're not going to leave y primes in the answer when you do the second derivative in implicit differentiation. You're going to substitute it back in using like your middle equation that you came up with. All right, and that's it. So stopping right there.